thankful for invitation to conference organizing committee. I consider it, and thank you very much. Ketone bodies under normal conditions synthesized in liver in different physiological conditions such as starvation or fasting or the consumption of ketogenic diet. Ketogenic diet may increase the level of ketone bodies and free fatty acids in the blood, which may evoke alteration in energy metabolism and increase the fat metabolism, evoke ketosis. Under normal condition, under normal condition, brain cells use glucose for energy production via Krebs cycle and glycolysis. Under ketogenic diet, level of free fatty acids increased, whereas glucose level decreased in the blood. And under these conditions, liver cells, hepatocytes convert free fatty acids to ketone bodies, which ketone bodies release from hepatocyte across the blood-brain barrier and enter into the brain cells via MCTs. Under this condition, brain cells use these ketone bodies for energy production via Krebs cycle. Ketogenic diet and nutritional ketosis have therapeutic effects in patients with, for example, cancer, mitochondrial diseases, neurological diseases such as epilepsy and anxiety. In spite of that, an advantage of ketogenic diets is the relative absence of side effects. But these ketogenic diets have also short and long-term adverse effects, such as gastrointestinal problems. In addition, the protocol may be very difficult to maintain, and foods can be unpalatable. Consequently, new therapeutic strategies are needed to maintain nutritional ketosis, which have therapeutic effects. So, to get a solution to the risk of ketogenic diets, numerous ketogenic supplements, ketogenic precursors were developed, which ketogenic precursors were tested in our study. Ketogenic precursors dose-dependently and rapidly elevate ketone bodies level in the blood and evokes ketosis, but without fasting or severe dietary restrictions. It was demonstrated previously that these ketogenic precursors may mimic the metabolic and physiological effects of the ketogenic diets by changes in metabolic physiology and neuropharmacological pathways. For example, these ketogenic precursors may increase the level of ATP and adenosine. These effects may mediate the therapeutic effects of ketogenic diets. Consequently, it is possible that this exogenous ketone supplementation could mimic the therapeutic efficacy of ketogenic diets for certain diseases such as anxiety disorders and epilepsy. It has been demonstrated previously that, for example, GABA-A receptors, serotonin 1A receptors, NMDA receptors, and nucleoside adenosine receptors are potential targets in both against anxiety disorders and in absence epileptic activity. So, based on these results and based on our expertise in the therapeutic use of ketogenic supplements and use of different animal models, aims of our studies were investigation of these exogenous ketogenic supplements on absence epileptic activity in study 1 and on anxiety-related behavior in study 2. So we hypothesized that these supplements can modulate both absence epileptic activity and anxiety-related behavior in vagri rats. Vistan albino vagri, Vistan albino glaxo, named vagri, sorry. Just a moment. Sorry. Vistan albino glaxo raceweek rats were used in our study, which rats developed seizures, which appear between 60 and 80 days as spike wave discharges in EEG. Normal and typical SVD contains trains of asymmetric spikes, asymmetric spikes and slow waves. These rats show different behavior features, such as behavior in mobility and so on under the SVD. 8-month-old vagri male rats were used in our studies, which rats were housed in standard laboratory conditions. We implanted electrodes, screw electrodes, for EEG recording. We implanted screw electrodes above the frontal cortex and parietal cortex and above the cerebellum as a ground electrode. After implantation, all electrodes were soldered to a Tampa in socket, and finally we used dentaculated cement to fix electrodes and the socket to the rat skull. These pictures show a place of electrodes on the rat skull, which was prepared to demonstrate implantation of electrodes for electroencephalography and electroretinography to my students. Consequently, we used only these electrodes and the 10-pin socket for EEG recording. We record EEG by an electroencephalograph attached to a data capture and analysis device. We recorded EEG for 2 hours, after 30 minutes adaptation, and these periods were split into 60-minute sections and were evaluated separately. SVDs were separated manually from EEG and were checked by fast Fourier transform analysis. We used the elevated plasmid test to study the effect of 7 days application of ketogenic supplements on anxiety behavior of our rats. This apparatus consists of 2 opposite open arms and 2 opposite closed arms with 40 centimeter high wall. Each rat was placed in the central square opposite to the open arm. This test, based on aversion of open spaces and fear of heads of our animals, and consequently proclivity of the movement to the enclosed arms. As reduction of anxiety is indicated by increase in the proportion of time spent on the open arms and increase in the proportion of entries into the open arms, we recorded the time spent on the arms and the number of entries into the arms for 5 minutes. All rats were fed with standard rodent chow, as this slide shows, and all ketogenic supplements were gavaged orally for 7 days. Ketone ester and KSMCT, which was a mix of ketone salt and MCT oil, were used by intragastric gavage, which were developed mixed by Dominic D'Agostino at USF. Thank you very much for this. with cooperation with others. We assigned our animals into 5 groups. First of all, we adapt our animals for EEG recording and gavage. After it, we applied water gavage in relation to group 1 and group 2 to get pre-treatment control SVD number before EEG recording. In relation to group 3 and group 4, all rats received intraperitoneal saline injection before EEG recording on the 5 consecutive days. And in relation to group 5, all animals received saline intraperitoneally, and 30 minutes later we applied water gavage. After control treatment periods, we applied ketone ester and KSMCT for 7 days, and because it was suggested that adenosinergic systems have a role in the effect of ketogenic supplements on seizures, we used the A1 adenosine receptor antagonist, DPCPX, in the animals of group 3 and group 4. So 0.2 and 0.5 milligram per kilogram DPCPX injected intraperitoneally. In relation to group 5, on the 6th day of KSMCT gavage, 30 minutes before it, we used DPCPX, a lower dose of DPCPX. We injected it intraperitoneally to our animals. Of course, we measured the blood glucose and beta HB levels, and we measured the body weight. In relation to study 2, study 2 was similar to study 1, but ketone ester and ketone salt and KSMCT were used. We assigned animals to 4 groups. And the first group was the control group, water gavage group, and animals of group 2, group 3, and group 4 received ketone ester, ketone salt, and KSMCT gavage. After it, we measured glucose and beta HB levels and measured body weight. And before the last measuring of blood glucose and beta HB levels, we used EPM. This slide shows that ketone ester and KSMCT gavage didn't change the glucose levels. This slide shows the effect of ketone ester and KSMCT gavage on SVD number and beta hydroxybutyrate level. We find significant decrease in SVD number after ketone ester and KSMCT gavage between 3rd and 7th application day. And on the post-treatment day, when we applied only a water gavage, SVD number returned to the baseline level. In relation to keto levels, after 1st and 7th ketone ester and KSMCT gavage, the levels significantly increased. And similar to SVD number, on the post-treatment control days, these levels return to the baseline levels. So we can conclude that ketone supplementation increased blood beta HB levels and reduced SVD number. We demonstrated that lower dose of DPCPX didn't change the SVD number, but high dose of it significantly increased the number of SVDs between 13 and 19 minutes after intraperitoneal injection. In relation to group 5, we applied a lower dose of DPCPX before KSMCT gavage on the 6 application day. And as this slide shows, this treatment abolished KSMCT, evoked a decrease in SVD number on the 6th day of KSMCT gavage, when without DPCPX, KSMCT significantly decreased the SVD number. In relation to study 2, we demonstrated that ketone salted KSMCT significantly increased the blood beta HB levels after 7th gavage, whereas only ketone ester decreased the glucose levels after the first gavage. After KSMCT gavage, on the 7th day, all rats spent more time on the open arm, and less time in the closed arms. In relation to the number of entries to zones, KSMCT decreased the number of entries to the closed arms. So we can conclude that ketone supplementation increased the blood beta HB levels and reduced anxiety on elevated plasmids in relation to KSMCT. It was demonstrated previously that frontoparietal cortex, thalamic structures and connections between them have a role in the absence epilepsy genesis by highly synchronized activity of thalamocortical and corticothalamic circuitries. It is widely accepted that cortical focus in the peripheral region of the somatosensory cortex initiates SVDs in animal models. In hyperexcitable neurons in the somatosensory cortex may increase the cortical excitability, which evokes imbalance between neuronal processes and increase the cortical excitability, which initiates SVDs. On the first cycles of SVD, somatosensory cortex drives the thalamus, and after it, thalamic structures will be recruited into the oscillations, and after it, these two areas of the brain drive each others and results in SVDs. Briefly, somatosensory cortex triggers the thalamus, and thalamus sustains the SVD, named cortico-driven and thalamic sustained theory by Miran et al. And yes, it was demonstrated previously that, among others, GABA-A receptors, serotonin 1A receptors, NMDA, and adenosine receptors are implicated in the pathomechanisms of SVD genesis. We demonstrated previously that GABA-A receptor agonist Massimol significantly increased the number of SVDs, whereas GABA-A receptor antagonist bicuculin significantly decreased the SVD number, suggesting the main role of GABAergic system in the thalamic GABAergic system in the absence epilepsy genesis. Moreover, clomipramine significantly and dose-dependently increased the SVD number, likely by means of its noradrenaline and serotonin reuptake blocking effects. In addition, non-competitive NMDA receptor antagonists significantly decreased the SVD number, suggesting that NMDA receptors have a role in the SVD genesis. We investigated the non-selective adenosine receptor antagonists, theophylline, and the A2A receptor antagonists on the SVD genesis and SVD number, and this slide shows that these drugs significantly decrease the SVD number. We demonstrated in the study 1 that higher dose of DPCPX significantly increased the SVD number, suggesting that theophylline exerted its effect via A2A receptors. We know that GABA A receptor antagonists, serotonin receptor antagonists, NMDA agonist antagonists, and adenosine receptor antagonists decrease the SVD number, whereas GABA A receptor agonists and A1 serotonin receptor agonists increased the SVD number. Consequently, we concluded that the role of GABA A receptors and serotonin 1A receptors, NMDA receptors, and mainly A2A adenosine receptors in ketone supplementation evoked decrease in absence epileptic activity, likely possible. In addition, we demonstrated that higher dose of DPCPX significantly increased the SVD number, and non-pro-epileptic lower dose abolished the KSMCT gavage evoked decrease in SVD number. Consequently, we can conclude that ketogenic supplementation may alleviate absence epileptic activity via A1 adenosine receptors, at least in Vagri rats. Adenosine may exert its effects via A1 adenosine receptors pre- and postsynaptically. For example, A1 type of adenosine receptors decrease the release of glutamate by decrease of calcium channel activity, and this receptor may hyperpolarize neuronal membrane by increased activity of potassium channels. It was demonstrated that ketogenic diet and ketone bodies may increase the adenosine signaling by both decreased expression and activity of adenosine kinase, which enzyme may metabolize adenosine, and by enhanced beta-HB metabolism. Consequently, by these changes, level of adenosine increased after ketogenic diet and use of ketone bodies. In addition, it was demonstrated that A1 type adenosine, the expression of A1 type adenosine receptors decreased in the pre-symptomatic Vagri rats. Consequently, we can conclude that ketogenic diet and ketone supplements effect on SVDs are in accordance with cortical focus theory, and ketone supplementation may decrease absence epileptic seizures by increased adenosine levels and A1 adenosine, increase adenosine levels and decrease the level of A1 adenosine. It was demonstrated that somatosensory cortex, prefrontal cortex, hippocampus, and amygdala, and connections between these structures have a role in the anxiety disorders by HP-axis and brainstem subcortical areas. It was demonstrated that activity of hippocampus and amygdala increased in patients with anxiety disorders, and consequently, we can conclude that the balance between the limbic and prefrontal regions and connectivities between these and other brain areas are disturbed in patients with anxiety disorders. Similar to absence epilepsy genesis, among others GABA A, serotonin 1A, NMDA, and nucleoside adenosine receptors are implicated in anxiety disorders. We know that GABA A receptor agonists, GABA analogs via GABA A receptors, and other drugs via increased serotonin levels and A1 receptors have anxiolytic effects similar to A1 receptor agonists such as buspirone. NMDA receptor agonists or antagonists also decrease the level of anxiety, whereas in adenosine receptor knockout mice and after caffeine treatment, increased level of anxiety was demonstrated. So we can conclude that all these receptors have a role in the anxiety disorders and have anxiolytic effects. If we, based on our results, and if we compare the putative mechanisms by which ketogenic supplements evoke its effect, anxiolytic or anti-absence epileptic effects, we can conclude that ketone supplements may exert their effects on absence epileptic activity and anxiety levels, likely via A1 adenosine receptors. After ketogenic supplements and ketogenic diet, level of beta-HB increased, which ketone body entered the brain cells through MCTs. A switch from use of glucose to use of beta-hydroxybutyrate, for example, decreased the activity of glycolysis. In addition, different ionic channels use ATP, which changes result in decreased ATP levels. Decreased ATP levels may increase the activity of ATP-sensitive potassium channels, which changes may hyperpolarize neurons. Moreover, ATP levels increased under this condition, which ATP metabolized rapidly to adenosine, which adenosine can be transported to the extracellular space by adenosine transporters, and ATP release from the cells, which rapidly metabolize to adenosine by ectoenzymes. Consequently, increased level of adenosine and increased activity of AE1 receptors may hyperpolarize the neurons, and in addition, this type of adenosine receptors may decrease the excitatory effects by decrease the release of glutamate. These inhibitory effects may decrease the cellular excitability and neuronal activity, and we can conclude that these inhibitory effects could decrease appearance of the absence epileptic seizures and attenuate the hyperactivity of brain areas implicated in anxiety disorders. Positive relationship was demonstrated between SVD number and anxiety level in long-event rats, which effects abolished by ethosuximide. This suggests that there may be a common pathophysiological basis of these diseases. We can conclude that ketogenic supplements evoked effects which decrease absence epileptic activity and decrease the anxiety levels, maybe via common pathophysiological mechanisms, for example, by adenosinergic systems, likely A1 adenosine receptor. So we demonstrated that ketogenic supplements may decrease the anxiety level and SVD genesis. I'm thankful for scientific cooperation to Dominic D'Agostino and Csillari at USF, and Gábor Juhász, Katonai Kékesi, and Árpád Doboi. And finally, what will be the better motto of this lecture in the United States, which motto based on our results and hope and classical sci-fi movie film, then thank you very much for your attention.